In this lesson, we're going to look at section 14.1, which is roots and radicals. Some vocabulary words, some of them you have seen before. We have our squared number, a number used as a factor 2 times, which means a number times itself. And so the examples are x squared and 4 squared, meaning x times x and 4 times 4. When a number is cubed, just like our volume, we have a factor of 3. So y cubed is 5 times 5 times 5, or 5 cubed is 5 times 5 times 5. When we have a square root, it undoes the square. Think of it as the opposite. So if b squared is a, then b is a square root of a, and it is written as b equals a square root of a. So for example, the square root of 25 is 5, because 5 times 5 is 25. And then we have a cube root, which undoes our cubes. So if we have b to the third power equals a, then b is a cube root of a, where b is the cube root of a. So we have the cube root of 27 equals 3, because 3 times 3 times 3 is 27. And so when we're looking at these and reading them, we have a couple different parts. The whole thing together is called a radical expression, and it's in the form of the nth root of a, where n is the index of the radical and a is the radicand. So the square root symbol, or the symbol here, is called the radical sign. And so, for example, we have the square root of 5 equaling 2 square root of 5, because 2 is not normally written. It's understood to be there, just like we have an exponent of 1 if it's just a single x. If there's no number written for your index, then it's considered to be the square root, or an index of 2. So again, here's our symbol. It's called the radical sign. And the number in here is your index. And the number underneath here is your radicand. Type that because my handwriting is really sloppy with this pad. And so for the examples that they give us, we have the square root of 13, which has our invisible index of 2, and our radicand is a 13. For our cube root of -8, our index is 3, and our radicand is -8. Then we have the 6th root of 64, so our index is 6, and our radicand is 64. And again, that's asking you what number times itself. 6 times gives you 64 as an answer. And then finally we have the square root of 18. So this time they wrote the 2 in there, and our radicand is the 18. The square root of a negative number is not a real number. So again, the square root is asking what times itself gives you that number as an answer. And so there is no number that you can multiply by itself to get a negative, because remember, 2 negatives make a positive. And so the square root of a negative number is not no solution. It's not a real number. There's a group of mathematical numbers that are called imaginary numbers, and that's what that would fall into. And that's beyond the scope of this course, but just know again that the square root of negative number, the answer is not a real number. But we can take the cube root of a negative number and you'll get a real number, you'll get a negative number. Because, for example, the problem that they gave us on the previous page, the example was a cube root of negative 8. And again, it's asking for what times itself 3 times gives the product of negative 8. And so the answer would be negative 2, because negative 2 times negative 2 times negative 2 gives you negative 8. So you're allowed to have numbers that are underneath your radical sign. So your radicands can be negative if there's an odd. So negative is okay if your index is odd. And let me type that, because that's important to remember. And then it's saying we have actually 2 answers when we take the square root of a number. And the example that I will show you is the square root of 9. So if we have the square root of 9, we know that it's asking you what number times itself gives you 9 as an answer. And we can say that 3 squared equals 9. So our answer is 3. But negative 3 squared is also 9. So negative 3 is the solution as well. So just like orders of operation, there are some rules to make sure that we all are going to be coming up with the same answer at the same time. And so what they will talk about is the principal square root and the negative square root. Your principal is the positive number, and the negative square root they will show you by having the negative in front of your square root symbol. And so if you look here in the blue, the square root of a for the principal would be a. The negative square root of a, they want the negative answer. So they would want, in this case, the negative 3. When they ask for 2 solutions, then you would put the positive and the negative. So if they ask you, what are 2 solutions to the square root of 16? You can say 4 and negative 4, because 4 times 4 is 16, and negative 4 times negative 4 is also 16. So looking at these true-false statements, the principal square root of negative 25 is negative 5. Well, that's false, and there are 2 reasons why. Number 1, can't take. Okay, let's reword that again, make sure I'm saying it correctly for you. The square root of a negative number is not a real number. But then also, the principal square root of a number is always positive. So there's 2 reasons that that is wrong. And so we can say the principal square root of, make them positive, 25 is positive 5. And that would make it a true statement. For the cube roots, we are allowed to have negatives because remember 3 negatives would multiply to still be a negative. So the cube root of negative 27 is negative 3. Well, negative 3 times negative 3 is positive 9. then that 9 times negative 3 is negative 27. So that is true. And the square roots of 16 are negative 4 and 4. I use that one as my example. So that is true as well. So here's some examples for you to do. When you see a negative, make sure you're checking the index to look for odd or even, because one of them you will say it's not a real number, the other one you will be able to solve. We didn't cover the square roots of fractions. You'll want to take the numerator and the denominator separate, so we'll do the square root of 1 over the square root of 4, so that way the calculator does not give you a decimal answer. The square root of 1 is 1. For this example, the square root of 4 is 2, so our answer would be 1/2. And when you're typing in the cube roots, you will type in the number 3. Then you will need to do your second button with a caret. And your caret is that exponent button that's other than 2. And then type in your number. So for example, if we were doing the numerator here, the cube root of 8 would give us 2. So make sure that you're able to type that in the calculator correctly. And then notice these say to evaluate. These will not come out evenly. And so round your answer 3 decimal places. For 14, you can type it just like that, or 12. You can type 4 square root of 5, and the calculator know that means 4 times the square root of 5. Or for 14, negative 3 times the square root of 6. You don't need to put the times sign. The calculator will know that it's a multiplication of those two together. So go ahead and do these problems. And when you're ready, we will move on to the story problems. So a square flower garden covers an area of 68 square feet. What is the approximate length of each side of the square? Round your answer to the nearest hundreds. So we know that the area of a square is side times side, or side squared. The side length isn't 68. The total area is 68. So we're going to say 68 equals our side squared. And just like with our Pythagorean theorems, to get rid of the square, we're going to square root. So the square root of 68 equals our s. And rounding it to the nearest tenth gives us 8.2. So 8.2 feet equals our side length. So now for part B, it asks us to determine the amount of edging needed to create the border. And so the edging, if you remember from previous story problems, means the perimeter. And for a square, it's 4 times the side length. So we know the side length is approximately 8.2. And we multiply that, we get 32.8 feet of edging. And then they're going to tell us that it's $1.39 per foot. And so how much money are we spending on this? So $1.39 per square foot times, and not square foot, just feet. Sorry, I was thinking of area. So times 32.8 feet of edging will give us $45.59 for a cost. Now we have Barbara's Bombastic Bakery. She's installing a corner display for custom decorated cakes. And as you can see from the picture, it's a right triangle. And so we have to use our Pythagorean theorem here. Our a squared plus b squared equals c squared. And so the hypotenuse is the c, and this is our unknown. So let's put that first. C squared equals, it doesn't matter which one we put first, but they're the same anyway. So 3 squared plus 3 squared. And so our hypotenuse squared will equal 9 plus 9. And so C squared will equal 18. That's a bad 8. Let me try that again. There we go. So the length of the longest side, we have to take the square root of 18. And rounding it to the nearest tenth will give us 4.2. And those are in feet. The top of the display has a decorative edge around all 3 sides to prevent the cakes from falling off. How much edging? And so for edging of a triangle, we're just adding up the sides. So we have 4.2 plus our one leg of 3 plus our other leg of 3. So that will give us 10.2 feet. And the top of the display stand is to be covered by square tiles that have a side length of 6 inches. How many tiles will be needed? Okay, so first thing I notice is that this is in inches, and our units on our triangle are in feet. So we need to take care of that. Let's do our 6 inches and turn our feet into inches. There's 12 inches in 1 foot. And so for our length and or base and heights of our triangle, let me get the terminology right for our triangles, we have 3 feet times 12 inches per foot, and we'll look more at unit conversions in our next lesson. That gives us 36 inches per length there. And so they want us to find the area. Well, we know area is 1/2 times base times height. Our base is 36. And our height is 36. And so when we find that, we get 648. And now we're in inches. So we are in square inches. And that's the area. The tiles, they say, have a side length of 6 inches, so the area of a tile is 6 inches times 6 inches, since it's a square. So the area of one tile equals 36 square inches. And so to get the tiles needed, we are going to divide the area that we need to cover, 648, by the area of one tile, 36, and we need 18 tiles to be able to do so. Our last story problem tells us that a glass company is making a paperweight in the shape of a cube, and it has a volume of 91.125 cubic inches. What is the length of each side? So we know the volume of a cube equals the side length to the 3rd power, because length times width times height are all the same. And so this time they're giving us the volume, not the side length. So 91.125 equals that side length to the 3rd power. So one side length has to be the undoing of that, which is the cube root of 91 0.25. And if we take that, so we'll get a side length of 4.5. And that's in inches. So now they're asking us for the area of the base. So we know that the area is side squared. So that would equal 4.5 squared. And 4.5 times 4.5 would be 20.25. And since we're in area now, we have square inches. And so the surface area is the area of all of the sides. We have top, bottom, left, right, and front and back all the same. So we have 6 faces of the cube. Each face has an area of 20.25. And so that gives us a surface area of 121.5. And again, we're in square inches. Okay, if you have any questions on this lesson while you're going through the hawks, don't hesitate to send me an email. Make sure you screenshot the problem you're working on. Otherwise, I'll see you next time.